I did a bit of reading into this. This is Grandi series, right? And aren't both option B and C correct, as both are Farley's approaches to the problem? The correct answer is 1/2 as per the solution set. Okay, let's take a look. So yes, this is the famous Grandi series. It goes like this. 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on, so on, so on. First, let me just tell you guys what my answer to this question is right away. It's option D, none of this. And the reason for that is because this series diverges in the usual sense. Diverges means that this right here does not converge to a finite value, so it's going to be none of this, alright? But I do want to show you why and how people might interpret this series. So let's have a look. First, maybe we can do the following. When we have 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on, so on, so on. Well, 1 minus 1 is just 0. And then if you look at 1 minus 1, that's again 0. And then 1 minus 1, it's of course 0. And if you continue, you're just adding infinitely many zeros, so the result is just equal to 0, right? So that it looks like we have option B for the answer. But what if we do the following instead? Second way, 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on, so on, so on. Instead of putting the 1 and minus 1 together and get 0, what if we save the first 1? It's just like when you make the first dollar, you want to keep it. And then you want to borrow $1 from somebody else and then use it. So, minus 1 plus 1, that gives you 0. And then minus 1 plus 1 gives you 0. And then minus 1, the next will be a plus 1. I just didn't write it down. That would have been a plus 1, so that would be 0. And so on, so on, so on. In this case, we should end up with just 1, right? So that suggests us option A is the answer. Okay, now we have some disagreement. And usually when this kind of things happen, you can see that the truth is the nth partial sum does not converge to a finite value. That's why this right here diverges. So that will be it. However, how do people get 1/2? Well, you can look at it this way first. 0 and 1, maybe you want to make everybody happy. So why don't we just say the answer is 1/2, which is the average of 0 and 1. Everybody should be happy in that sense, right? Well, maybe not. Okay, let's talk about a more legitimate way to see why and how we end up with 1/2. So the third way, you actually have two ways to look at how we can get this 1/2 right here. But I'm going to just do this right here. 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on, so on, so on. We can first look at this as a geometric series. Putting the series form, let's use n starting at 0 and it goes on to infinity. To get to the next number, we just multiply by -1. That's the common ratio. We put it inside here and we just have to raise that to the nth power because I started at n is equal to 0. Plugging 0, -1 to the first power, we get 1. Plugging 1, we do end up with -1. Plugging 2, it is +1 and so on, so on, so on. And let me just remind you guys right here. Note, when we have a geometry series with a common ratio r and raised to the nth power, this right here should just be the first term, which plugging 0 into n, r to the 0th power is 1, over, it's always 1 right here, and then minus the common ratio. That's a formula for adding up the geometry series. So maybe we can do that right here. The first term is 1, and then the common ratio is -1. So if you do that, that is 1/2, right? So maybe we should just use the geometry series formula to get the answer. So answer is C. Well, no, this is actually not true because the reason is because this right here, because in order for us to use this formula, we have to be careful with the detail. The detail is that this only works if the absolute value of the common ratio is less than 1. Meaning, under this condition, this right here converges. If you don't have this condition, this right here does not converge. That means you cannot use this formula. In our situation here, r is equal to -1. If you take the absolute value, of course, this right here is 1, which is not less than 1. That means we are not allowed to use this formula. So in fact, C is also incorrect. A, B, C are all incorrect in the usual sense. But now I do want to mention the following. Assuming you are just taking a pre-calculus class or calculus class, then that's how you will answer it. This right here diverges, done deal. However, sometimes we do want to continue with the math. Sometimes, even though we have a divergent series, we still want to give an answer to it. In that case, we say the following. This is depending on if you are taking like a higher level math, right? So this right here is called the Caesarean summation. In that case, what we will do is 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. We are going to assign, so this right here, we're just going to assign an answer for this series, and we will assign 1/2 to be the answer for that. Well, you might be wondering why not assigning 0 or why not assigning 1? We assign some value to something that we didn't have an answer to. And the truth is that this is not the first time you are seeing this kind of things. Because before, when you saw square root of -1, how would you answer this? You will say this right here has no answer, right? You cannot have square root of a negative number. However, technically speaking, this right here has no real answer because we can answer this as I, which is the imaginary unit. I is defined to be I squared, giving you -1. And I is called the principal square root of -1. So we assign something to something that we didn't have the answer to. Why did we do this though? Well, in fact, once we did this, we can actually continue with the math. Even though I is called the imaginary unit, but we do have real-life applications with I. You can look at some differential equations, things like that. So the truth is, you can actually continue with this kind of series. There's a fun one for you guys. If you do 1 plus 2 plus 3 plus 4 and so on, so on, so on. In the usual sense, this right here is just going to give you infinity, right? But you can assign the value -1/12 for the answer for this. You can look up Ramanuja summation. You can look up the zeta function. You can look up a video by Man Profile. I will link the video in the description for you. And one more before we go. If you have taken some calculus integrals, then the integral, let's say we have -infinity to infinity of x. Technically, this integral diverges. It has no answer for it. But we can say this is equal to 0. And again, this is more like a higher level math. We will say this as the Cauchy principal value. And put a CPV for this equality. That's it.